Welcome to the revision by Alphaphysx for IGCSE 0625 P6 exam. In this revision, we'll be going through the worksheet shown on the link below. First of all, this paper is an alternative to practical, which means each experiment is provided to you by a drawing or by description is exactly as given. You cannot make your own assumption. Here, for example, when you start to record the readings, you have first to empty the beaker, because the beaker is already given with some water in it. Second is the choice of range for the measuring scale you are using. It should be suitable to whatever you are measuring. You need to use a ruler for small distances and a micrometer for very small distances, that is less than 1 millimeter. Here, for example, the student had a wrong choice of a scale. He chose the scale to record a reading up to 10 volts, while his reading, his pointer, shows only a very small deflection on the scale. While if he used the scale that is up to 1 volt, his pointer would shown up here, which is a little bit more than 8 or less than 8, which exactly can't be shown right here. According to the scale used, each small division right here represents 0.2 volt. So the reading is about 0.8, but is it 0.8.1 or 0.8 or 0.79? He can't tell. The second point is all your measures must be recorded in a table. And in the table, you have to point out two things: the degree of precision and the significant figures. And this is what we need to discuss. First of all, significant figures. Which figure is a significant and which one is not? How many significant figures would I write? First of all numbers from 1 to 9 are significant, so we do not have any troubles regarding them. But the one that we need to consider is the 0, because the 0 is significant or not, it depends on its position in the figure you are writing. The third is how many figures to write down. Now you need to agree about the degree of precision and about how many significant figures you are going to write. And we will start by talking about the significant figures. Which figure is significant and which one is not, and how many should I use? Any number from 1 to 9 is significant. So if you have a figure like this one or like this one, and you need to count how many significant figures are there, you'll just count them. This one is 3 significant figures, this one is 4 significant figures. The one that you need to pay attention to when you write is the 0. 0 is only significant in the following cases. Number 1, when it lies between two significant figures. So 5, 0, 0, 0, 5 is 1, 2, 3, 4, 5 significant figures. But if you have the same number written like this, so this one is only 1 significant figure. The second is the decimal point. If you have the 0 to the right of the decimal point and to the right of a significant figure, so it's also significant. So 12.00, these are 4 significant figures. But 0.005, this is only 1 significant figure. But 0.0050 again, these are 2 significant figures now. 1.0050, this is now 1, 2, 3, 4, 5 significant figures. As a practice here, we have 1.50, so these are 3 significant figures. These 3 again are 3 significant figures. This one is not counted. 0.005, so this one is 1 significant figure only because there is no significant figures here. 1.005, this now turns into 4 significant figures. Now, the figures you write in the raw data should meet the degree of sensitivity or the degree of precision on the scale that you are using. All readings, for example, for a meter ruler are precise up to 1 millimeter, regardless how many significant figures you write. You can write 5.2 centimeter or 14.6 centimeter. The first one is 2 significant figures. The second one is 3 significant figures. Still, when you record the reading and you have no millimeters on it in the reading, you can write it, you need to show it. So my reading will be 15.0 centimeter. It means that there are no millimeters in this reading, but you must show it in your raw data so that you have consistency in the degree of precision that you have. What about processed data? When you record your data in a table, as we will discuss now, you need to show the headings. So this is a distance in centimeter, voltage in volts, current in ampere, resistance in ohms. As you see here in the table, all the readings are to the same degree of precision, to the hundredth in the volt, and again to the hundredth in the current. But when you do your calculation to calculate the resistance is equal to the voltage divided by the current. Here you will divide a number that has 2 significant by a number that is 2 significant, but here you have 3 significant figures, and here this only 2 significant figures. So the rule here is that any processed data should be to the least number of significant figures in raw data, which means when I divide 1.01 by 0.32, I should write my answer in 2 sig fig, which in this case, if you use your calculator, you will see that the answer is 3.156, which actually you will write it only as 3.2.